Great.
Right. So I am going to declare this meeting open. And thank you everyone for joining us this evening. I'm Annie Lloyd. I'm the branch coordinator of CPRE Northumberland. I'm very pleased to welcome you to what is our last event of the summer season. I should first of all mention that I am recording this session now. So if that doesn't suit you and you want to switch off your camera, then you are very welcome. Or alternatively, please leave it on because sometimes it's nice for the speaker to actually see human faces out there. We've centred our events in CPRE Northumberland this year around climate change. And Matt, who I'm about to introduce you to now as our speaker this evening, spoke to us back in spring to our little climate action group, actually, here in Morpeth in Northumberland. I was really impressed with his presentation and I promptly booked him for this event. I am, however, going to let Matt introduce himself because in his intro, he is about to explain to you all his background and what he describes as his nerdiness. And I should just mention that this is a free talk, but if you'd like to consider looking up CPRE Northumberland, following us on social media, or even joining us, we are a membership-led organisation and we're always looking for new avenues and collaborations. And it's great to see a lot of new faces on this call. So with that, I'm going to shut up and I'm going to hand over to Matt. Matt, thank you.
Thank you, Annie. And I'm just going to share my screen, I hope. Share. Hopefully you can now see my screen. And if I go into my slideshow mode, you should see me plugging in an electric car. And what I have prepared and what I've been doing for the last few years since I retired is kind of encouraging the use of electric cars as a way of reducing your expenditure on transport and also reducing your CO2 emissions, and particularly around older electric cars, because not everybody has 30 or 40,000 pounds to spend on a new car. So and I think there's less support and people trying to sell older electric vehicles and encourage their use. So that's what I've been doing, and that's why Joe Electric came around. Why Joe Electric? Really, as I said, it's because Matt Electric sounds rubbish. Joe Electric kind of trips off the tongue a little bit better. So a little bit about why I talk about electric cars. I'm a mechanical engineer.
Matt, can you hear me? Just before we go
Yes.
ahead, can I just check with everybody? Can everybody see the slides okay? And can everybody hear Matt okay? Can you just give me a thumbs up or just say yes? Yeah, okay. Some
Yes.
nods, some thumbs up, great. And will you let me know of any problems as we go along? Thank you.
Oh,
sorry.
Okay, good. Yeah, so what do I know about electric cars? There's a lot of information, tends to hit the headlines in newspapers and on websites, scare stories. But so, why have I got some knowledge to be able to talk about the subject? So I'm a mechanical engineer, chartered mechanical engineer, and I've been responsible for design and service of electric vehicles for 25 years with high-speed forklifts, which was my career. Since 2021, I've been the joint owner of a used electric car, and we've done about over 40,000, nearly 50,000 miles in it now, including some longer trips. So I've sort of dealt with the range anxiety. Sorry, there was a comment there.
No, I think if people could just mute their comments, if they if you could all just mute, that would be helpful, unless you're wanting to interject with a question. And I'm sure that Joe will mention how to ask questions in a moment.
Indeed. Thank you. Thanks, Annie. And finally, I have recently qualified to maintain electric vehicles. So I completed the Institute of Motor Industry Level 4 in the maintenance of hybrid and electric vehicles at my local technical college, so that I can fix them as well. Well, I haven't needed to yet, but I'm ready to if the need arises. So that's why I've sort of become a little bit of a nerd on the subject. So what I'm going to cover today, an introduction to electric cars and the terminology that is used around them, some of the challenges and issues with older electric cars, some myths about them, how to use an electric car and save carbon, reduce your carbon footprint, and save money with an older electric car. And finally, to look at the impact of driving an electric vehicle on one's carbon footprint and for me as part of a household. So obviously, no surprises about climate change. You've been talking about it, and I think this slide, it's a US slide, but kind of shows the changes in the temperature of planet Earth over the recent years, and just the alarming acceleration of temperature. And I'm here. I'm lucky enough to be on holiday this last 2 weeks in Greece on an island which has typically had a wet season, which started in the middle of September. And so the season has finished because people here expect it to be wet, but it isn't, because there isn't a wet season. The wet season is coming later and later each year, and the place is very, very brown and dry. So, it's changing this part of the world, maybe even more so than the UK at the moment, as desertification hits the Mediterranean region. It's quite alarming how the climate here has changed. So my first thing I was going to talk about, and this is a little bit, I'm sure a lot of people will already know this, but I wanted to give it to everybody as a bit of sort of basic stuff, so that I'm not losing people, is the different types of electric vehicles that are out there. Firstly, hybrid cars. Hybrid cars use a petrol engine to charge a battery, which can drive the wheels in place of or as well as the gearbox. So you'll have seen these around, and there's two major categories of hybrid. The first of them are called or known as mild hybrids, and these are fairly conventional cars which use a small motor and battery to improve the efficiency in a largely conventional vehicle. And you will know these because they can only move when the engine is running. So they cannot drive under electric power at any moment. A lot of them are labeled or known, have a little badge on them that say 48-volt hybrid, and that's the voltage they normally run at. There's quite a lot of them available, particularly from Hyundai and Daewoo, and they are a step in the right direction as a more efficient vehicle, but a relatively small step on the way to lower carbon footprint and higher efficiency. And then we go on to the other grouping of hybrids, which are the true hybrids. These are higher voltage vehicles that have a battery voltage of something in excess of 250 volts, and the battery can drive the car without the engine. And the Toyota Prius set the standard in this type of vehicle over 20 years ago. The Toyota Prius is an amazing vehicle, tremendous reliability and life, and these vehicles have exceeded everybody's expectations. A lot of taxis, of course, you will, I'm sure, have been in a Toyota Prius at some point if you've used taxis, and they're a good improvement in the efficiency, particularly in urban driving, city driving, stop-start driving. Finally, and I said there were two classifications. That was not completely correct. There is the extension of the true hybrid, which is a plug-in hybrid electric vehicle, also known as a PHEV in some materials. And this is a hybrid which has got a larger battery, which can run for a significant distance without the engine. So we're talking about between 10 miles and 60 miles of range without the engine. And the intention is that the battery will be charged with mains electricity, because that's where the efficiency saving is really achieved. And for short runs, the vehicle can be operated electrically around town. And mixed views of these vehicles. I think that they are certainly more efficient than conventional petrol engine vehicles. There's a risk that in later life of the vehicle, its use on mains electricity may decrease. So while it may be highly efficient with its first owner, I see the risk that as it moves into the second-hand and third-hand market, it maybe will operate more normally on petrol rather than charging. But that's not an unproven theory. So finally, let's go on to electric cars. True electric cars, which have no petrol or diesel engine at all, and they rely entirely on electricity stored in a high voltage battery. The famous one, of course, particularly to you in the northeast of England, the first one to the UK market, the Nissan Leaf, made in Sunderland, and in the UK, it is the most common electric vehicle on the road. The initial version, the one in the picture on the left, their first version looked a little bit bubbly and a little bit novel. The later version looks more conventional and both of them are very good vehicles, very good cars. I'll talk a little bit about the differences in the sort of 5-year-old vehicles and the capability that they have, and the more recent vehicles that are available on the used market, which have got a much greater capability than those first generation vehicles. The second one I would really highlight is the Renault Zoe, which is made in Flins, near Paris. I hope it's pronounced Flins. And it's the most common electric vehicle on European roads, and was really the second to market in the UK after the Nissan Leaf, and is a very capable vehicle. It's small, it's a mini-sized car, but getting a tremendous reputation for reliability and for longevity. And as a used vehicle, I think is very much worth considering if it's big enough for your purpose. The next one, which I obviously should talk about, is the Tesla, and now the best-selling electric car in the world, Tesla Model Y and Model 3. The European vehicles are made in China, although Tesla has factories also in Berlin and in the USA, of course. And superb vehicles, groundbreaking in efficiency and performance, but not cheap. But as they come into the second-hand market, they've got tremendous potential as their value decreases for those of us who don't, naturally spend huge amounts of money on cars. Finally, I wanted to talk about the Chinese market because the Chinese apologies, I got myself muted by mistake there. Finally, I wanted to talk about the Chinese vehicles, and the 50% of the electric cars being built in the world are being sold in China. So there is an enormous number and an industry that has developed at extreme speed to produce tremendously cost-effective electric vehicles. And the one that's hit the UK market most in the greatest numbers, of course, is the MG4, which is this one here, the orange one. It's getting a very good reputation. But we're also going to see, particularly in the coming few years, more and more vehicles because these vehicles are being built in huge volumes, and volume means lower cost and higher reliability. And so there's a lot to be said for these Chinese vehicles. There are issues, of course, that have been in the press around subsidies and and competitiveness and European consideration as to tariffs, etc. But those are the really sort of major models that I think have affected the market in the last few years. So this is a kind of look at what's happened to sales of electric cars in the last few years. I'll just see if I can get this on my screen a bit. So this is the new car sales, the share taken by electric cars in the last 5 years. And you can see the tremendous growth we've seen over 2020, 2021, 2022. And we've seen a flattening off in the percentage of the market taken by electric cars, particularly in 2023 and into 2024. And so I wanted to talk a little bit about why has the increase stalled, which, had we kept in this kind of a gradient, obviously we'd be heading way toward, well towards the government's targets for electrification of the market. And we're now heading in a direction which is somewhat less than in keeping with the expectations of our climate change plans. So why is the electric car growth stalled? I think some of it has been down to myths and a skeptical press. We've seen in the newspapers scare stories about electric cars, and part of what I've been doing, or why I wanted to start talking about electric cars as Joe Electric, was to try to counter some of the myths that are out there. Charging infrastructure is talked about. It's never perfect. We would like to be able to have a charger available every time we feel like getting a charge, and that's not always possible. But in my experience, the charging infrastructure is sufficient. You can get where you need to get to. It may take you a little bit longer than it would take you in a petrol or a diesel car if you're making a long trip, because it may take you half an hour, 45 minutes diversion from your route to get a charge. That is true. It's not perfect. I think another thing that's affected the market is interest rates. Everything became more expensive to borrow money on. And secondly, insurance premiums. And insurance premiums on electric cars have stepped up, particularly in the last 2 years. When I first got my electric car, the insurance premium was the same as a petrol car. It's now a little bit more, maybe £100, £150 more to insure that electric car than it was for the petrol car. I think that's a temporary thing because there are insufficient people to repair damaged electric cars. That's led on to higher premiums. Fortunately, the savings in fuel more than make up for the insurance premium difference. Government signals, I think, have been an issue. The government moved out the deadline from 2030 to 2035, and that has kind of given a signal to people that not to worry about electrifying. However, the zero emissions mandate, which has not been repealed by the UK government, does require manufacturers to sell an increasing number of electric cars in each year between 2024 and 2030. Sorry, about 2035. So this is really throwing the impetus onto the industry to deliver what the government wanted to walk away from, which was this deadline for phasing out. So it's causing something of a difficulty. Whether the government backs down on it is yet to be seen. But essentially, manufacturers will be fined if they fail to sell enough electric cars in each year between now and 2035. So that's going to be an interesting one to watch. But I think government signals have been a problem. The last thing I think I would raise is that the residual value of used electric cars has fallen over the last 2 to 3 years. And that's because the number of cars coming off lease has increased radically. So that as the number of used vehicles on the market has increased, that has reduced residual values. In turn, that increases the lease price of new cars because the lease price is based on the new value minus the value at 3 years old or 4 years old at the end of the lease. And so that's actually pushed up the monthly cost of leasing a new car. And many buyers of electric vehicles have taken the safe route, and leasing seems like a sensible option with an electric car. What happens if the battery fails after 4 years? These are the kind of things people are worried about. And of course, if you're a leaseholder, it's not your problem. So leasing, has been more than 80% of electric vehicles sold have been on lease, and that's been attractive. But the fall in residual values is kind of making that equation harder to get right. So, but every cloud has a silver lining. It means this is a fantastic time to buy an older electric vehicle because the values have come down very substantially in the last 2 years. So used electric cars got cheaper in the last 2 years. Not enough people buying them. And some other reasons behind that. I think used card dealers, I'm not quite sure, it sounds like a poker player, but I think dealers, particularly smaller dealers who tend to handle a lot of the second-hand market, are continuing to do what they always did. They sell and service petrol and diesel cars that they know about, and they're not really pushing used electric cars that come onto their forecourts. I think secondly, used car buyers are looking for a good car for reasonable money. They're not looking for a project, like fitting a home charger. That's not what's on their mind when they're buying a used car for taking the kids to school and doing the shopping. So that's kind of putting people off. And I think finally, buyers are wary. We've all bought petrol cars. We kind of know what it sounds like and what it smells like if it's bad. Not professionally, but we've done it all. But we've all done it before. Whereas with electric cars, people are just a little bit uncertain because they haven't got personal experience of it. And that's what I sort of wanted to do through my website, joeelectric.com, and through this presentation. It's just trying to make people feel a little bit more confident about getting involved with older electric cars. A couple of examples here, and these are just taken from a Northern Ireland site. And these are cars that are, here's a car here that's, will certainly have a range of 150 miles for the next 5 years for £10,000. And, that's a cheap car. And that's a car that can save people money for 5 years to come. Relative, it's low risk as any used car ever is. You can't say, when you buy an older used car, you're not getting that warranty that you get with a new car, or with a top or with a premium, straight brand, dealership supplied warranted used car. And then if you've got for lower money, this is the first generation Nissan Leaf, a car with that'll give 80 miles range easily for the next 5 years, for £8,000, and this would be lower now than it was then. So really, what I'm seeing is that the prices of sort of 3 to 5 year old electric cars are now £2,000 to £3,000 less than they were 2 years ago. So the value of these cars has come down, and we're in inflationary times when everybody's talking about the price of everything's gone up. Well, let me tell you, there's the price of one thing that hasn't gone up in the last, through this hyperinflationary period we've been through, and that is the price of used electric cars. They have got cheaper.
Can you get that, please?
So ideas about what, buying a used electric car. Where would you go? How do you do it? And the same. These are the same rules that apply to petrol cars too. Do you buy from a private seller? And of course, there you have limited redress, and you don't have a warranty from a seller. Do you buy from a smaller dealer? And my experience there is that quite a lot of them have limited experience and knowledge of what they're selling, and they're not really that they're not able to help you much more than you can help yourself. You can buy from a franchise dealer. You can buy from the local Nissan dealer or Renault dealer. And yes, they know what they're talking about. I have never had any experience of the franchise dealers not knowing their business. They do know, but they're charging for that. And they are giving you a premium service and a premium price. So when you see the forecourts of those dealers, you'll see prices that are significantly higher than you'll see if you go online, or if you go for a magazine that sells cars or something like that. You'll see higher prices. And so what I've been doing with Joe Electric is trying to answer the question, where can you go for objective advice about older electric cars? And that's what Joe Electric is trying to do. And that's my website, joeelectric.com. And I just try to keep it updated with good articles from the press and pieces of advice about older electric cars. What I'm trying to do is encourage older electric vehicles to get used for more miles, because every time we use an older electric vehicle to do miles in place of an older petrol or diesel vehicle, it gives us less CO2 emissions. Also, if we can encourage the market, we can raise used EV prices, and that'll ultimately have a knock-on effect on new EV sales. So Joe Electric is really, trying to sell anything. I'm not in business. I just want to try and help people avail of the cost savings and the benefits available with older electric cars. Any questions at that point? Shall I stop and just see if there's any questions have come through? Anybody got any questions? Anyone to go off mute and hit me with something?
Sorry, Steve has a question, Matt.
Great, Steve.
You've been talking about the limited amount of expertise. What's the position with emergency, AA and RAC expertise?
It's increasing well. Yes, I think that those guys are up to the play. And I have met with quite a few of them when I was doing my training course at the Tech. There were quite a lot of AA and RAC personnel being put through those courses. So they have equipment on some of their vehicles to recharge cars that are perhaps out of charge somewhere, and their technicians are being skilled up. Some interesting sort of facts about their call-out rate. The call-out rate for the AA, who do a survey on this every year, is lower for electric cars than it is for petrol cars. So they are seeing, yes, they occasionally get a call out where somebody's run out of juice somewhere and needs to be rescued. But the lower general breakdown rate more than makes up for that. Electric cars have so few moving parts that there's very little to go wrong with them. So they are proving to be, very reliable in general use. So that's not the experience, and that's been the opinion shared by the AA and RAC people I've been training with, and it has been largely those people who've been on the course with me.
Thank you.
Good question. Good. Let me talk about truths and... Sorry, any other questions? Apologies.
Hello, yes. Can you hear me?
Yes, I can indeed.
Hello, I'm Keith from Northumberland. I can't see myself on video, thankfully. I don't know if you can see me.
You're where I am. You're where I am.
All right.
Yes.
Could you clarify a little bit about what age you're talking about in terms of second-hand used EVs? I've been looking at something cars literally as we're speaking. This is 23 reg cars, SUVs, sort of Vauxhall Mockers, Peugeot 2008, Citroens, and a small handful of others that are between £15,000 and £18,000 with less than 10,000 miles on the clock. I mean, that is really cheap. It's on par with petrol, isn't it?
Yes.
So when we're thinking of second-hand used EVs, we don't need to be thinking of 5 and 10-year-old things. No. We're looking at something even a year old with only 2,000 miles on the clock.
Correct. There are some like that. I have not seen huge numbers. I think the big peak is at 2 years and 3 years, because there are 2-year leases and 3-year leases, which are where the cars are coming off lease at that point. And I think there's more of those cars coming off lease than the market can deal with, and that's just driving values down and making great buys. Fantastic deals out there.
Yeah. Okay. So thank you.
I agree with you. So some truths and myths about electric cars. Let me move on a little bit. So the first one, obviously important to us in terms of the carbon footprint, is, do electric cars really reduce carbon emissions? And this is some data from the Transport and Environment Research Group, which is a European research group. And this was recently published by The Guardian. I think pretty well reviewed material. And this is the lifetime emission of the vehicle. So this is the emissions in the manufacture of the vehicle, as well as its use over its lifetime. And so what we're seeing there is, in the first line, we've got a petrol vehicle with a lifetime emissions of around 250 grams of CO2 per kilometre driven. And when we go to a hybrid, we're seeing a reduction of about 20% on that. So that's important. That's useful. And And with a plug-in hybrid, a little bit more than that, 26% less. When we go to a full electric vehicle, we've got 69% less, which is obviously radically different. So we could have 2.5 electric cars driving around to give us the carbon emission of a single petrol car. So over the lifetime, these electric vehicles do seem to have a very substantial overall reduction in emissions per powertrain. And that is, we're talking there about carbon, about CO2. And of course, there are many other emissions which are problematic, particularly with diesel, but also with petrol. So electric cars have the higher embedded CO2. So they start with more. This first line here is how much of that CO2 is in the manufacture of the vehicle. It is higher at the point of delivery to the customer, but then in use, the emissions are so much lower that we see the radical overall improvement. So hybrids and plug-in hybrids are significantly better than petrol cars, but not as good as electrics. So we would need 2.5 people moving to a hybrid to get the same CO2 benefit as one person moving from petrol to an electric car. So they really are radically better. Just a quick danger, if you're interested in plug-in hybrid vehicles, particularly, just watch the numbers. There is some official data for plug-in hybrid cars. And this is driven by, it's an EU source of data, which actually suggests that they're more efficient and less polluting than they really are. I've got some of the evidence for that on joeelectric.com, my website, but it is a little bit of a glaring problem with the data, and it's going to take some years for the EU to correct that. Finally, I would say that to maximize the CO2 savings from older electric cars, it's important that we keep using them so long as they are replacing necessary petrol and diesel cars for shorter trips. So, if we don't get the second-hand life out of our fleet of electric cars that are in the used market, we will not get the maximum climate benefit from them. We need to use them to replace petrol and diesel cars. Certainly, it's better to ride a bike, it's better to walk or take the bus. But if you've got to drive a car, try and do it. It's obviously better for the environment to do that with an electric. And just on the range thing, the average car journey in the UK in the latest data is 8.4 miles. So range is sometimes pointed to as more of a problem than it really is. I want to talk about depreciation, and we sort of touched on it in a couple of the questions. Depreciation on electric cars, new electric cars anyway, is higher than on equivalent petrol models, mainly because they are slightly more expensive when they're new, and they have the same end point, so therefore they do depreciate more quickly. Depreciation levels is similar to luxury petrol and diesel cars and sport utility vehicles. So they're not outlandishly higher, depreciating outlandishly higher, but they are depreciating more quickly than petrol cars. And part of that reason is that electric cars have been getting better over the last 10 years. And that's kind of put a premium on the more recent models and devalued the 6-year-old, 7-year-old, 8-year-old cars, making them exceptional value because the 3-year-old or 2-year-old vehicle has a greater range. So if you want the lowest cost motoring, it's going to be electric. And if you buy a car with the range that you need, that will give you the lowest cost. And there are vehicles out there that will do particularly a second car task, taking kids to school, going to the shops, taking granny to wherever, easily for less than £5,000. Perfectly good vehicles in great condition, because the early adopters looked after their cars. People with electric cars weren't doing donuts on the street corners. They were washing their car every Sunday afternoon. They're really good cars out there. I want to talk about range and how far will a used electric car take you. It depends on how big the car is and how much it's carrying. Same as efficiency of any vehicle. If you're carrying a load of stuff, it's going to use more energy. It's not going to go as far. But I think one of the things that I learned that surprised me is what's happening in the UK car market. And that is that the average weight of new cars being sold in the UK has increased by 100 kilograms since 2013. So there's 100 kilograms is, it's a lot of weight. That's an extra big person in your back seat. And that is causing the CO2 emissions of the average car in the UK to get worse, not better. So I would encourage anybody to think carefully about buying a really big, heavy car, unless there's a good reason to have it. They are being marketed heavily because the industry can make more margin on them than it can on smaller cars. But that's really, I think, encouraging a lot of people to buy bigger than they necessarily need. I want to talk about how big the battery is in a car. This is the range question. The battery capacity of an electric vehicle is like the size of the fuel tank in your petrol car. The bigger the fuel tank, the further you can go. The bigger the battery, the further your electric car can go. Within the limitations of weight and size, obviously, if you've got a huge electric car, it needs a big battery, a bigger battery than a small electric car. So bear that in mind. So the size of the battery is measured in kilowatt hours, which is a bit of not an easy term for people to latch onto, but it's an important number to watch if you're interested in buying an electric car, because this is the size of the fuel tank. And when you look at an advertisement for an electric car, that's the number to look for. It's sometimes confused by another number that's used in the advertisements, which is kilowatts, and that's the power of the electric motor, which is irrelevant if you're buying an electric car. The only one you're interested in is the size of the battery, and that's the number in kilowatt hours. So the first generation of electric cars, which were sold in the UK, like the Nissan Leaf and the early Renault Zoe, had batteries which were between 24 and 30 kilowatt hours, which gave a range of between 80 and 120 miles. And that's when the car is slightly older. It would have been higher than that when the vehicle was brand new. And I'll talk a little bit about battery life and how it affects range in a moment. But since 2020, electric cars are generally having battery sizes of between 40 and 70 kilowatt hours, giving them a range of 150 to 300 miles. And the range is always a concern for people. But I would particularly focus on people who have two vehicles in the house. Do you really need two vehicles with a really high range? And if you have two vehicles in the household, one vehicle with a smaller range is quite a good way of getting around the town efficiently. So, and again, talking about range anxiety, 72% of car journeys in England are under 5 miles. And that's from the 2021 National Travel Survey. So, 80 miles is quite a long way if you're driving 5 miles at a journey. Of course, how far you can go depends to some extent on how fast you drive. So driving style and speed makes a significant difference to the range of an electric car, as it does to the efficiency and the emissions of any car. If you drive the pedal to the metal, you're not going to get a particularly good miles per gallon in your petrol car, and you will not get the same range in an electric car. In my experience, in our little Renault Zoe, we've got a range of well in excess of 200 miles if we drive at 55 to 60 miles an hour. If we drive at 70 miles an hour or 70 and a bit on the motorway, it's less than 150 miles. So you do really see that air resistance having a devastating effect on range, as it does on the efficiency of a petrol car when you drive fast. Wanted to talk about aging of car batteries. This is a subject that I think is not necessarily understood all that well, even by dealers selling them. And this is that electric car batteries age and they lose some capacity over the years. And it's a little bit similar to your phone battery. If you've got a mobile phone, the battery will diminish over a few years. And what I would say about electric car batteries is they're much, much better than phone batteries. And we're talking about life in excess of 10 years, whereas, a phone battery is, likely after 4 or 5 years to have gone. So there is a similar tendency. They do lose a little bit of capacity every year, and it's something to consider. But the aging is very slow and predictable. Now, the battery condition is measured by a state of health, same as it is on an iPhone or on your mobile phone. And this is the percentage of the original battery capacity that remains right now. And dealers should have this information on cars they're selling. The service technician can read it from the car, but a lot of dealers don't understand this, and some tend to only advertise it if it's a good number. So it's certainly something to be worth looking for from a dealer if you're buying a vehicle. And if you're looking at several vehicles, then one would think about that number as more important than necessarily the miles on the clock. On the number of miles the car has performed is what percentage of the original battery capacity now remains. Now, in my little Renault Zoe that we've been running now, and we bought it at 2 years old, it's now 5.5 years old. It's got a state of health which is about 89% now after 5 years. And that means that instead of doing 220 miles as it could when it was new, it can do about 200 miles. And that's 5 years on. I think that's pretty good. So in terms of the calculation I was just doing there, so if the original range of a car when it was new was 200 miles, then if its battery state of health is 75%, which is likely to be 10 years old or so, its range would be 150 miles. And so that's a reasonably straightforward calculation that you can do if you get that state of health number from the guy you're buying the car from. Now, the loss of battery capacity and likewise the range of the car is very predictable. The batteries are aging in a pretty linear fashion, so they're losing about the same amount every year, although they do have a higher loss in the first year. So in year 1, you can expect a little bit more than you will in the remainder of the years. And generally, this is a good news story. 5 years ago, the press was saying, oh, these batteries are all going to fail. These batteries are not going to last. And the data is showing a good news story. The batteries in the common models in the UK are lasting really well. And I've got some data on my website, which is from a large fleet of electric cars of all different types, which kind of shows really how they are lasting. And it's really a good news story. Even the cars with batteries that are performing the worst are performing better than anybody was expecting 5 years ago. So it really is a good news story, but it can't be ignored. If you buy a 10-year-old electric car, its range will be significantly lower than it was when it was new. So long as you're aware of that and are planning for it, it's not necessarily a problem. So batteries do age better if they're looked after well. So first thing is that high ambient temperatures are bad for battery life. And that makes the UK a great place to operate electric cars, especially the northern regions like we are in Northern Ireland and Northumberland. It never gets hot enough to do any damage to an electric car battery. South of France, south of Spain, you really would need to keep it out of the sun and avoid overheating of the battery. Not a problem for us. Frequent fast charging is not great for the battery, and driving really hard is not good for it. So an easy life does improve the life of a battery, as you would expect. Finally, leaving the car charged to 100% for long periods can accelerate aging somewhat. That's not one to fret over, but a lot of people would tend to leave their car charged at 80% if they're going away for a week or not intending to use the car for a long journey. It's quite useful just to charge it to less than 100% and charge it to 100% if you're going on a long trip, which is what we generally do. Now, batteries have warranties, and usually that warranty will transfer with the vehicle. And the battery warranty is 8 years with Renault, 5 years with Nissan, However, this covers failure of the battery. It doesn't cover aging. So the aging needs to be considered outside of a warrantable matter. Finally, last point I wanted to make is that the range of electric cars is lower on very cold days. And this is a picture of my little Renault on a very cold day. And on that day, its range would be between 10 and 20% lower than it would be on a normal, typically, above zero day. But the good news is that cold does no harm to the battery, unlike high temperatures. High temperatures will damage the battery. If it's 40 degrees for a week, that's not good for your electric car. But low temperatures, no matter how low they are, is not damaging the battery. Any questions about batteries while I am at that point?
Can you see one question from Linda?
Linda. Can't hear you, Linda.
Linda, can you unmute?
Is that better?
That's better.
Oh, can hear you now.
Wonderful.
Yes,
okay, thank you. Sometimes you hear that people change an engine out for whatever problem. Can you do that with a battery? If there's a fault that with the battery, can you swap it out and buy a new battery and just put it in the car?
That's really not happening. And the reason is that the cost of new batteries is so high that it's very rarely worth doing that. Buying a new battery for a car that you've maybe bought for £20,000 or £15,000 would probably cost £15,000 because they are such an expensive component. So that really isn't happening. Part of the reason is that batteries aren't going wrong, so there's no need for people to change their batteries. And part of the reason is that there aren't a lot of people who are doing the work. And that's one of the issues that does exist, is that there is a shortage of technicians on older electric vehicles. So finding somebody who would actually do that job, I think, would be very difficult at the moment. We'll talk about a little bit about the servicing question as we go on. The good news is it's very rarely happening. I think what is happening is that where there are accidents involving electric cars, very often the default action by the insurance company is to write the vehicle off, rather than take any risk to there being something wrong with the battery that could later cause some kind of a mishap or a fire. So, and I think that's part of the reason that insurance premiums for electric cars have crept up in the last couple of years. They're generally being written off after accidents which would not cause petrol vehicles to be written off.
Oh, okay, thank you for that.
Hello.
Sorry, carry on. Yeah.
Hello. I can't see things here, so am I talking to you?
Yes. Yeah, I can hear you.
Oh, hello there.
Keith.
Yeah. I'm one of many thousands of drivers with a caravan, and it seems that I can pick up pretty much any reasonable size petrol or diesel car to tow a small to medium size caravan, but that's completely not the case with electric cars. I've been to your website, and it says that I forgot where it's gone.
Towing, generally not.
Towing is not encouraged, I think the expression is. I wonder if you could give us a little bit more of a picture on that. Basically, in the olden days, for decades and decades, and many cars, and so on, I would look at a car specification and look at the towing capacity, and it would tow X amount of kilograms. And when I'm now looking at EVs, they're throwing some curved balls into it. And we were looking at the Renault Scenic, and that's telling me that it can tow my caravan fine with a driver only. So if my
Yes.
wife gets in the car, we're now over the limit, and that's ludicrous. What they're saying is,
Absolutely.
if
Yeah.
if you're putting anything in your car, the caravan is now not towable. And then the other side of it, of course, is because there's my understanding, it's more that the drag of the caravan impacts on the range of
Aerodynamics.
the aerodynamics. It impacts on the zoom. You've got a loaded car. You're going on typically aeros and dual carriageways with no scope for regeneration in the battery as you're tootling along. And that in this country, you might well be in cooler temperatures, and then you start towing it. You can cut your range by half or even more.
I would imagine so. Yes.
So
Yeah, it really hasn't. You know, the electric car industry has, in its first few years, really ignored the towing challenge, and the reasons are that they are, you know, aerodynamically very efficient, and the electric cars are designed to minimize energy usage. Because that energy usage is heating up the battery, it's heating up the motors in the car. So they're aiming to keep the power usage as low as possible. And putting a caravan on the back kind of really has gone contrary to everything they've tried to do in their design brief. So certainly I would have said, and I have said on my website, not generally advised. However, I was warned by Annie that this question will be asked, and I done some research.
Thanks, Annie.
On the subject, and there's an autocar. Now let me just go to another share if I can. I hope I can share another page here if I did this right. No, where is it?
I mean, the other option, Matt, is not to do that now, but to send.
I'll send the link. I'll send the link to the site.
Happy with that.
Yeah. I will. I'll send it. Sorry about that. I thought I had the other one open, but I don't. So I won't mess. I'll try. I'll mess myself up if I try now. So the bottom line is, in the last couple of years, there have been models which are allowing towing. Tesla has taken the lead on that. And Teslas are showing some quite significant towing capacity, particularly their Y model. Now it's pricey, of course, but BMW have followed that, and some Mercedes electric vehicles are following on to what Tesla has led with. I think some dangers are the same thing. You're going to have significantly lower range. And it could be less than half the range, I would imagine, because the drag of a caravan. I've got a caravan myself, and I know what they do to the fuel consumption of a petrol car. It's going to have quite a devastating effect on range. But I'd also have a concern that if you're going to cross the Alps, I just don't know how much of the battery and the motor will remain by the time you get to the top of the pass. But within reasonable bounds, I think shorter journeys with lighter trailers are perfectly possible now. But I'll include that article from Autocar, which is quite good, in a note to Annie. Does that answer your question, Keith? No. Just being honest.
Hang on. Yes, I was on mute for a second ago. Yes, thanks ever so much, you did. I'll take a look on Autocar as well. Thanks very much.
And I'll pass that on to you, Keith, when I get.
Yes, I'll send that link out.
Thanks a lot. Much appreciated.
After the meeting.
Thank you. Thank you.
So ideal uses. It brings us nicely to ideal uses of older electric cars. The first point I'd make on that is, if I can get rid of this thing in the middle of my screen. Go away. Right. One of the factors that is important, and particularly becoming more important, is that having a home charger and low cost nighttime electricity is really necessary to get significant fuel cost savings with an electric car. The rates at public chargers have gone up, and so the savings available by charging from public chargers has diminished. So I would seriously consider a home charger as part of your package. And that's obviously a real problem for some people who don't have the ability to install a charger. The truth is, without a home charger, your cost savings are significantly diminished. But for cars regularly used for town driving, maybe 15 to 50 miles a day, could easily be replaced by a first generation Nissan Leaf. That's the sort of bug-eyed one, or an early Renault Zoe as a second car in a household, ideally. These are available for less than £5,000 now. Fitting a home charger, probably £1,200 is a reasonable budgetary figure. But the savings available in fuel it very much makes that worthwhile. And if I do have on my website a fuel cost calculator that will show, based on the miles that you do, how much it can save you on fuel. It's very significant. For us, more than £2,000 a year saving in fuel based on using the electric car, between £2,000 and £3,000 for me per annum. So secondly, for replacing petrol or diesel cars used on longer runs, including motorways, doing 25 to 150 miles a day and longer runs, maybe using public chargers for top-up. Ideal use for Leaf and Zoe with larger batteries, and there are a lot of Hyundais out there and Daewoo's, which are available for £10,000 or less. Certainly less than £10,000, and then with installing the charger, you're talking about something like £11,000 to set yourself up for that kind of a used car, which will save you again a couple of £1,000s a year in fuel every year. There are real savings to be made with these vehicles. Now, finally, if I can get rid of this stupid thing that keeps showing on my screen, get out of the way. Right, sorry, I got rid of it. So. Finally, I would say if you're inclined to suddenly need to drive 400 miles at short notice, if you're doing a lot of towing, if you've got unplanned getaways, or you do foreign driving holidays in Spain, and if those are your thing, electric cars may not be ready for you. France is well served. Germany, Netherlands, well served. Spain, no. Northern Europe, yes. But it's not right for everybody. I wouldn't pretend it's right for everybody. And if some of the people who could make it happen were able to convert, it would make such a difference to our carbon footprint. So talking about carbon footprint, I wanted to talk, and I'll just stop there for questions before. I wanted to just sort of show the impact of this on my carbon footprint, just as an example. Any questions before I do that? Great, let me just sort of tell you about my carbon footprint. And I started about 2021. I did one of these. You do a survey online and look at your buying habits and your holiday habits, etc. And so what I've talked about here is what are my household CO2 emissions. And this is not a good story, by the way. My household CO2 emissions in 2021 were between 20 and 30 tonnes per annum. That's 4 adults in the household. And that's really made up like this. I've got oil heating in my house because we have no gas in where I am, in a rural environment, and an old house. And so that's between 3 and 5 tonnes of that is in heating oil and electricity. Driving in 2021, between the 4 of us driving 20,000 miles a year in 2 diesel cars, was between 4 and 6 tonnes per annum. Food and drink for adults, between 7 and 9 tonnes per annum. Goods and services, that's buying stuff, that's buying consumer goods and services, internet services, etc., between 3 and 5 tonnes. Air travel, between 3 and 5 tonnes per annum between the 4 of us. And that's what made up our 20 to 30 tonnes per annum as a household. And this is pretty easy calculation on one of the many internet sites. So what really I've achieved since then, between 21 and 2024, still using between 3 and 4 tonnes on oil heating and electricity. I've done a few things that have impacted that. On electricity, replaced an old freezer, found an old freezer which was using a bizarre amount of electricity. And if you have a freezer that's more than about 10 years old, it really is worth having a look at replacing it. I certainly got less than 2-year payback on a new freezer. Air fryer has made a significant difference. Low energy light, so but saved about a ton there. Food and drink, we have changed our diet a little bit. Not gone vegetarian, not gone vegan. But I have a slide on that. Let me just show you that. This is kind of broadly a view of what diet does to one's carbon footprint in annually. A meat lover at 3.3 tons per annum, average at 2.5 tons. Somebody who doesn't eat beef, 1.9, vegetarian, 1.7. The important thing for me is it's not about whether you're a vegetarian or a vegan. It's just making choices meal by meal, and we have reduced our carbon footprint of our food. The big one for us has been driving, and that is we've gone from between 4 and 6 tons of carbon emissions per annum as a household to between 1 and 3 tons. So we've saved 3 tons of carbon dioxide emissions per annum with one electric car, and that's because nearly everybody drives the electric car. So whereas we used to have 2 diesel cars doing 10,000 miles each, now we've got 1 diesel car doing maybe 4,000 to 5,000 miles, and everybody wants to use the electric because it's so much easier to drive, fun to drive, and it does what you need it to do. Talked about food and drink, goods and buying stuff. We haven't really, I can't say we've made a significant change there, so I've left it as it is. Air travel, we have saved about a ton. We use more ferries, particularly between, I'm in Northern Ireland, between Northern Ireland and the UK, using the ferry generally where we can instead of flights. And in terms of, this is the kind of numbers for me as to what the impact is. If I take a return flight to London from Belfast, where I live, it's 0.125 tons. But if I fly to Florida, it's about a ton. And we're just nipping away at that. But we have to. I'm in Greece today, so I can't claim to be a climate purist. So what else could I do? I could fit solar panels, and that's probably next on my list of what I should do. I could save about 1.5 tons per annum by installing solar panels, and that would be a big lot of solar panels. That would be 10 square meters of panels, which is big, which is about £12,000 of cost, and I'd get a payback in about 12 years for doing that. I could get a heat pump to replace my oil heating. Now, for me, that's a real problem because our house has got solid walls. Before I could insulate them, I'd need to do something with the roof. So I'm thinking it would cost me something around £80,000. And it would give me a 60-year payback on a heat pump. Now, you've got some grants in England. So you have a £7,500 grant, which would improve that situation. Still not a great return. I could move to 100% renewable electricity. And I've thought about that. But for me at the moment, there's really no great option to do that. And it would cost me about £500 a year to do that. And that would save me about 1.5 tons of CO2. I would like to do that, but I haven't really found a way of doing it. But essentially, the point I wanted to make is that moving it to an older electric car delivered more than 50% of the reduction. It was the easiest reduction to achieve, and it also saved big money as well. So for me, it was an all-round winner because of the cost savings as well as the carbon reduction. And that's really all I wanted to say about what Joe has been doing. But I'm open for questions at this point. So any questions at this point, or maybe on the carbon footprint kind of element, or anything else?
It doesn't seem like we've got any questions.
I've got one.
Right.
Oh, good.
I'm not entirely sure of my information here, but I understand that there is a facility to use these car batteries for energy management purposes and generation and feeding into and out of the home. Can you tell me something about that?
There's a couple of elements of that. I think there's some thought that a smart electric grid will have some significant impact in the next few years. And that would be where your car charger is connected to the grid and allows, firstly, smart charging so that your car gets charged when there's surplus electricity available in the grid.
Yeah.
And I've signed up for a scheme in Northern Ireland. I think there are similar schemes in England whereby this is possible, which just means that your electricity supplier can decide when your car battery takes charge. So that, for example, it wouldn't charge at a peak time when they don't have enough electric to go round, and they can time your charge to happen at 2 in the morning and 3 in the morning when there's surplus on the grid. Then your energy supplier would steer you the energy at that time, which is good for everybody. And they also reflect that in the price that they charge you for the electricity. Those schemes are sort of in their infancy, but I think they're really showing promise. And I'm seeing, in England, energy suppliers supplying power for electric cars are offering some amazing nighttime rates of a few pence per kilowatt hour compared to what I'm paying, which is probably 16 pence per kilowatt hour. So there are some great deals out there. I think the longer term thinking there is that it could also be possible for your energy supplier in a few years' time to actually take power from your car battery when it's connected to the charger and overcome a short-term blip on the grid and take a little bit of power from your battery to help keep keep somebody's life support machine working in a hospital someplace, which is maybe a little bit of extreme. But that's one element. The second element is where used car batteries could become available to augment people's home energy system. And that would be where your own car, where a car battery, perhaps from a used electric car at the end of its life, could be installed in a second life using your solar panels to collect the energy and drive your kettle at 7 o'clock in the evening. That is kind of talked about. It isn't happening, I think, as much as anybody hoped. And partly because the standardization in electric car batteries has not happened. So every car that's coming onto the market has its own battery, and it's unique in its management system, so that for anybody to start turning a particular model of car into a home energy system is kind of risky, because that model's only going to be around for a couple of years, and then it could change, and they've lost their route to market. So disappointing that I think there was a possibility that we could have seen some standardization in electric car batteries, which would have facilitated their use in that way, and that didn't happen. I suspect there's maybe no way back from that at the minute.
Thank you, Matt.
We've got 2 questions in the chat from Linda.
Yes, good.
Linda, do you want to ask these, or shall I? I think Linda's muted, so I'll ask quickly.
Yes, great.
Can you see these? Linda says, do you feel that road tax on EVs will cause problems for the EV market now? And then she's got a second question. I'll let you answer the first, please.
Okay, the road tax. A bit of a blow that we're going to see from next year, road tax on electric vehicles of, I think, £165 per annum. And that's a bit of a blow, yes. But given that, for me, I'm saving over £2,000 a year by driving electric, it's not enough to make me change the economics for me. It will, maybe influence some people who are more, closer to the margins in the justification. Maybe people who are doing smaller mileages than me, whose savings per annum are lower with an electric car. A bit of a disappointment, but I suppose there was an inevitability to it. Somebody has to pay the road tax.
And the second part of Linda's question was, are the batteries fully recyclable now? Great point.
It is a good point. They are they can be recycled. So far, they're not being recycled because cars are not coming. Car batteries are not coming to the end of their lives yet. So nearly all the electric cars that have been built are still running, and there's a very small number of batteries requiring recycling. So that at the moment, I understand in the UK, there's almost no capability for recycling batteries. There's almost I'm told there may be one site now operating in the UK, but until recently, batteries that were requiring recycling were having to be sent to mainland Europe for recycling. But it was a very small number of batteries. Once that volume becomes significant, and it will in 5 years, then the equipment and the facilities exist for it to be done. And there is a requirement in European legislation for the manufacturer of a lithium battery to accept it back for recycling. So this isn't something that is going to end up on a council scrap heap. It is the legal responsibility of Nissan to take every battery back from every Nissan Leaf, in the same way that it's the responsibility of Renault to take back every battery from a Renault Zoe, and that's the law. So, I don't think we're going to see lithium batteries showing up where they shouldn't. It's been quite well. The legislative framework is quite thorough to make sure that they are properly dealt with at the end of life.
That's great. We've also got a link in the chat from Fiona Greenwell. Thank you, Fiona. I think there's been adequate time now for people to make a note of that link if they wish to. That looks really interesting. I'll certainly be following that up on Radio 4. And I think that's it in terms of questions. Has anybody else got any questions not in the chat box that they want to ask in person? And no hands are going up, so I think that is my cue to thank you very much, Matt. That's been an absolutely fabulous talk, really stimulating and informative, and most of all, really hopeful and optimistic in feel. I think this is a talk that has captured the zeitgeist. So many people now are either switching or thinking about switching. You talked about the early adopters. Not only, they're also making useful and sometimes quite evangelical mentors as well for the rest of us who are sort of dragging our heels a bit more. And although we're nowhere near the sort of bulge in the bell curve as yet, I can see that getting nearer and nearer all the time. I've learned so much, and you've managed to cover so many aspects of a very, very interesting and emerging field. Personally, I'm really also reassured by the reliability of batteries and aging, because some of us are not only dependent on our e-bike batteries as well, to which I can need to work, but I have a built-in battery, my cardiac pacemaker, so I have a sort of an extra investment in the reliability of battery technology and increased capacity. So it's been fabulous. Another thank you as well to everybody who's attended.
Indeed. Thank you.
Absolutely great to see you all on the call, and to see you during the call, obviously debating and discussing and thinking about the issues and interacting. I have been recording this. That will be available to anybody who wants it. I'm just stopping